is just picking out a particular term, and the theory is if you can find one term, you can find them all, and as you've seen, it's a lot of work if you have a high exponent. So this is just asking for example, the 9th term, the 6th term, the 12th term, the whatever term. Maddie, what are you doing? Where's your note package? Where's your paper? Where's your pencil? Yep. So we're going to talk about the kth term, which is hard to say. Don't get caught up in the k. It just means a generic term. So we know we're going to have some kind of combination at the beginning. We know we're going to have the first term, which is x to the something. And we know we're going to have y to the something. Easiest is the n value of the combination. Where does it come from? So how do we usually know what number to put right here? Maybe peek back from Friday and look at one of your expansions and see, where did that number come from? It's the n that's in the exponent of the question. So this n is that n right there. Now is it coming back? A little bit. I'm going to go back to the end of the second exponent because this is the second easiest to do. What's the relationship between the term number and the last exponent? Term number and the last exponent. What does the first term start with here? It's like we never even talked about this on Friday. Starts with a 0. And then in the second term it is a 1. And the third term it is a 2. And a 12th term it would be a, so this is the kth term, this is k minus 1. For the wordy people, that's just the term number minus 1. Now I'm going to go back to the r, because what's the relationship with something else in the question and r? It's the exact same, so it's also k minus 1. Minus 1, not 11. So it's also the term number minus 1. And all we need now is the exponent on x. What's the relationship between the two exponents? It adds up to give us n. So we call this n minus, and then in brackets, k minus 1. N minus k minus 1. And that's just from the two exponents have a sum of n. The two exponents have a sum of n. So I've done it left brain with all the notation. I've done it right brain with the words and the arrows. Now we'll do an example, which might work better for some people. So instead of expanding this all out, all they want to do is the 9th term. Again, the theory is if you can give one term, you can give them all, and this is going to eat up a lot less of your exam time than trying to give out this entire expansion. There's always a question like this on every exam for the last 5 years. I have no doubt there'll be one on yours as well. These are always 3-mark questions. You get a half mark for setting up each of the pieces, so a half for the combination, a half for the x, a half for the y, and then 1.5 for simplifying it completely. So we're going to have some kind of combination, which we'll fill in the n and an r in a second. We're going to have x squared to the something, and we're going to have a negative y to the something. Now there's 4 numbers you need to fill in, the n and the r of the combination, and the 2 exponents of each of the pieces. There's moments I feel more like a zookeeper than a teacher. I do the n of the combination first because I find it the easiest one to do. It has the least amount of thought. What does the n value have to be? 12. Why 12? Why 12? Because it's the exponent in the question. Then I go to the back and I do the exponent on the second piece, and that's got the relationship term minus 1, term number minus 1. So if we're looking for the 9th term, what's going to go here? 8. Then I go to the R of the combination. Where do I find the R value? It's also 8. Then the last one I do is the exponent on this first piece, and all I need to know is the sum. Something plus 8 gives me 12. What does the something have to be? Is 4. That's 1.5 out of 3. So you get a half mark for getting the 12C8, a half mark for getting this to the 4th, and a half mark for getting that to the 8th. The rest of the 1.5 is going to come just from evaluating. This is straight off your calc, a 12C8. $4.95 or $1.95? $4.95. Just looking for confirmation on that. He says magically without looking at his calculator. Yep. The middle term, I need to do x squared to the 4th. What's the exponent law? What do I do with these two exponents? Multiply them, so this is going to give me x to the 8. Here we just need to be careful with that negative because we know that the 8 applies to the negative and the 8 applies to the y. So in essence, that's negative 1 to the 8. So is it going to be positive or is it going to be negative? It's going to be positive. So I'm going to put the plus here, which we normally wouldn't. But just so when you look back, that's what happened to that negative. We didn't just ignore him. And then y to the 8th is just y to the 8th. And so the 9th term has to be 495 x to the 8, y to the 8. Isn't that way easier than writing out all the terms? Let's look at number 4. This was an exam question 3 years ago, I want to say. Instead of x and y, ooh, they threw a and g. So the 6th term of 2a plus 3g to the 8. And so I'm going to set up the pieces just like above. We're going to have a combination with something, something as our NR. We're going to have 2a to the something. And then we're going to have 3g to the something. I have an n, an r, and 2 exponents to fill in. I always start at the n because it's the easiest. What does the n value of the coefficient or the combination have to be? 8. Where does that come from? Exponent right in the question. Then I go to the back. What's the relationship between something in here and the last exponent? 6 minus 1 gives us 5. What's the relationship with the r of the combination? Also has to be 5. What does the first exponent have to be? Which is 3. Why 3? 8 minus 5. Questions on the pieces so far? Okay, give me an 8C5. Offer 56. That sounds confirmed. What do I do when I have coefficients in the brackets here? Yeah, just apply the exponent to each of them. So I'm going to keep the brackets till the next step. I need to do 2 to the 3 and a to the 3. 2 to the 3 would be 8. A to the 3 would be a to the 3. Keeping the brackets on the last term as well, I need to do 3 to the 5 and g to the 5. That sounded confirmed at the same time. 243, g to the 5. And what do I do as the very last step? Kind of. I don't need to distribute because I don't have any plus or minuses. Not quite done because I got numbers all over here. I got a 56 and I got an 8 and I got a 243, and what do I need to do with all of those? Multiply. I need to combine them, multiply them all. It should be a big number. looking for confirmation. And then what comes after that? Questions so far? So those are the straight up find a particular term. 5 and 6 are going to be the little application questions, you know, where they're a little bit different. So take a look at number 5 and see if you can figure out what's different between 5 and 3 and 4. What's different in number 5? Working backwards, yes, more specific. Why is it not as straightforward as 3 or 4? You got some fractions going on there, yes. What else? We don't know which term, so it hasn't said find the 8th, find the 6th, find the 7th. We don't know. All we know is it has to have an x cubed. The other thing that's different is both of the terms in the binomial have x's in them. So if you look back to number 3, it was x and y, and then a and g. These both have x's. Okie dokie. And all we know is we're looking for something with an x cubed. Okay, so we're still going to set up the same 3 pieces we did before. We know we're going to have a combination. We know we're going to have an x to the something, and we're going to have 1 over x to the something. Okay, so let's go in our same order. Can we find the n value of our combination? What is it? 7. If we come to the end, can we find our r value right away? Problem here, we need to do a little bit of guess and check, a little bit of logic. The problem here is I don't know this is 3. Because if I put a 3 here, what do I need to put here? A 4, and that's going to give me x cubed over x to the 4. How do I reduce something like that? So when you're dividing with exponents, what do you end up doing? Subtract. So if I put a 3 here and a 4 here, is that going to give me a total of x cubed? No. So we need to do a little bit of thought, a little bit of guess and check. If I put a 7 here, what's going to have to go there? So I'm just going in order. If I put a 7, that's going to be a 0. And I'm going to write it just for the visual people. You don't have to write it. And so in total, that's going to give us an x to the 7 over an x to the 0. And that simplifies down to x to the 7, not our x cubed. Okay, what's the next possibility? A 6 and a 1. What's that going to give us on the top? X to the 6 on the bottom, and x to the 1 if I simplify. X to the 5. Okay, what's our next possibility? 5 and 2. Okay, what does it give me on the top? X to the 5. X to the 2. So here is our only combination that's going to give us our x cubed. So we need to do a little bit of thought there to figure out what these numbers are. So I know this is a 5 and this is a 2. All I need now is the r value of my combination. Why does it have to be 2? Because it's the same as the last exponent. So we need a 7c2. Offer of 21. This is going to be x to the 5. This is going to be 1 over x squared. That's going to give me 21x to the 5 divided by x squared, which gives us, which is what the question asked for. Now the question asked which term. Have we told them which term it is? No, we know what its value is. We know its coefficient is 21, but how can I find out which term it was? It's got to come from this guy here. What's its relationship to the term number? It's minus 1, so this has to be the third term. Just pausing for you to digest. Any questions in there? Anything you're like, whoa, what's going on? Let's look at the last one. Another one of these applications where it's not just a straight up find this. They've given us a minus b squared to the 6, and we want to know what's the coefficient of the term that has an a3 and a b to the 6. Okay, we're going to start the same way we started all these, is just by setting it up. We know we have a combination. We know we're going to have a to the something, and we're going to have negative b squared to the something. Can I fill in my n on the combination? Has to be 6 because that's exponent in the question. Coming to the back, can I fill in my last exponent? Well, this is where we need to do a little bit of thought. I need this to simplify down to b to the 6. So if I've got a b squared, what needs to be on the outside? It has to be a 3, because that's the only way to get our 6 is when we multiply by 3. If this is a 3 and this is something and I need an a cubed, and I know these have to add up to give me 6, that's got to be a 3. And the r of the combination also has to be a 3. So we need a 63. Offer of 20. Looking for confirmation. A to the 3 is going to be a to the 3. Now we just need to be careful here with this exponent. It's got to apply to the negative, and it's got to apply to the b. So negative 1 cubed. So I'm going to throw a negative in front of the 20 there. That's where that negative ends up. And they end with a b to the 6. Why is that negative so important? Because what's the coefficient is what the question has asked, is negative 20 is the coefficient. If you lost that negative in the back, you're going to have positive 20. That's as hard as they're going to get. Yep, you'd lose a half mark.